The lesson for today will be gravity and magnetism. The TEKS are 112.14 Science Grade 3, beginning with school year 2010-2011. Knowledge and skills, force, motion, and energy. The student knows that forces cause change and that energy exists in many forms. The student is expected to observe forces such as magnetism and gravity acting on objects.
Good afternoon, boys and girls. My name is Miss Molina, and today we're going to be talking about gravity and magnetism. But before we begin, let's remind ourselves of our 3 basic rules here in the classroom. Rule number 1 is listen and pay attention. Rule number 2 is raise your hand if you want to get called on. And rule number 3 is be respectful of others. First, let's talk about gravity. Gravity is a pulling force. Earth pulls on objects with the force of gravity. The objects are pulled down towards the center of the Earth. The moon and other objects have gravity too. In fact, everything pulls on everything else because of gravity. But we only notice this pull when something is huge, like a planet or a moon. Which do you think would have less gravity, the Earth or the moon? The Earth actually has more gravity than the moon because the moon is 1/4 the size of the Earth. So the moon's gravity is much less than the Earth's gravity. It's 83.3% less. Also, do you think that you would weigh more on the Earth or weigh less than you would on the moon? Your weight on the moon is a function of the moon's gravity. So you would weigh less on the moon as you would on Earth because Earth has a greater gravity pull than the moon. Now let's talk about magnetism. Magnetism is the force between magnets. Magnets attract or pull on some kind of metal. A magnet can attract or repel or push against another magnet. These forces are magnetic forces. Magnets have 2 poles, the north and the south. The north pole of one magnet attracts the south pole of another. If you put 2 north poles together, they repel each other. So do 2 south poles. Earth is a huge magnet with magnetic poles in the north and the south. The magnetic forces of the Earth are different from the force of gravity. Why do you think that is? As we mentioned before, the magnetic forces of the Earth are on the North Pole and the South Pole. Now, gravity pulls towards the center of the Earth, not the North or the South Poles. That's the difference between gravity and the magnetism between the North and South Poles. What we're going to do next is we're going to test some objects to see if it's true that gravity does pull the objects to the center of the Earth. If we throw objects, do they normally stay up in the sky or do they come down? Let's test a ball, an acorn, a rock, and a plastic toy. First, let's throw the ball up in the air and let's see if it stays up in the air or if it comes down. Ready? 1, 2, 3. It fell down to the ground, to the earth. Now let's test the plastic toy. If we throw it up in the air, is it going to stay up in the air or is it going to come back down? Let's see. It didn't stay up in the air. Now let's see about the rock. On the ground. Now the acorn. The acorn fell as well. So that means that gravity is true, that the Earth pulls the objects down back to the Earth, and that's why they don't float, or that's why they don't stay up in the sky. What we're going to do next is we're going to use other objects to see if we can defy the laws of gravity. If I let go of some objects, they're supposed to fall down to the ground, according to what gravity is, that the Earth pulls objects down to the center of the Earth. However, what if I use a magnet to hold the object up in mid-air? Will it stay up in mid-air or will it drop? Let's see. Let's test this can. This is a magnet. If I let it drop without the magnet, it'll fall down to the ground. But if I use the magnet, do you think it'll stay up in mid-air? Let's see. The magnetic force of the magnet is keeping this tin can in midair. and it's not letting gravity take its course and pull it down to the ground. This screw is the same. It's supposed to fall if I let it go. However, if I use a magnet, the magnetic force on the magnet is not going to allow the screw to fall down to the ground, and therefore we're defying gravity. Let's test one more object. This is a clip, and it's staying up in midair with the force of the magnet. Now, what is a temporary magnet? A magnet attracts other magnets, and they can stick together with their magnetic forces. However, not all metals are temporary metals. Metals, such as quarters, do not stick to magnets. But a tin can will stick on to a metal. Why can't the tin can be attracted to the metal on the clip? They're not magnets. They're temporary magnets because of the metals that are in there, that they're composed of. Now that we've gone over what gravity is and what magnetism is, we're going to break up into groups of 5 so that you all can test some items that I'm going to provide you. You are going to use this magnetic board and several items in the Ziploc bag, and we're going to do some tests on gravity pull and magnetism using magnets and other objects. Now that we have completed our group assignments, we have a better understanding of what gravity is and what magnetism is. Don't forget that gravity is a pulling force, and the earth pulls on objects with the force of gravity towards the center of the earth. And magnetism is the force between magnets. Earth is a very large magnet because it has a north pole and a south pole.
For our last assignment, we are going to use this Venn diagram to compare and contrast gravity and magnetism. The characteristics for gravity are that it pulls, it stops objects from flying away, it is the center of objects, and it applies to all objects. Magnetism repels, it has poles of objects which are the north and the south, and it depends on iron or steel. What they have in common are that they are both forces, they are both invisible, gravity and magnetism both pull and attract, they are both fields, and they both cause movement.
Thank you very much, and I hope you enjoyed the lesson.